Okay, these notes are for slope and rate of change application problems. This is your concept number 2 in quarter 2. Now the first two examples are dealing with just regular slope. Okay? But if you read the example, it says find the value of x so that the line passes through the points 2, 3 and x, 9. So we're solving for this x value of the point. Okay? We know that the line has a slope of 3 halves. So the first thing that we do is we label all of our given information. So our first point, 2, 3, I'm going to label that as my x1, y1. My x, 9 is my x2, y2, okay, because it's my second point. And I know that my slope of 3 halves is going to be my m value. So if we think back to the last section, when you find slope, you use the formula of m equals y2 minus y1, so you subtract your y values, over x2 minus x1, so you subtract your x values. So now in this example, we're working a little bit backwards. I already know my answer for slope. I already know this answer is 3 halves. What I don't know is this one x value. So I plug everything into my equation. My m, my answer for my slope, is 3 halves. Equals, then your y2 minus y1, I know both of these values. I knew my y2 value was 9, and I knew my y1 value was 3. So I have 9 minus 3 in my numerator. Now my denominator, when I subtract my x values, my x2 is what I'm solving for. I don't know that number. So that's just simply going to be x. Then minus your x1 value, which was a 2. Okay, so I have 3 halves, which is my slope, equals 9 minus 3 over x minus 2. Okay, so my goal is to solve for x. Now this goes back to quarter 1 material where you actually have a proportion now. You have a fraction equal to another fraction. Because of that, when you have a fraction equal to a fraction, you can cross multiply. So in order to cross multiply, I have 3, this numerator, times the opposite denominator. So 3 times the entire x minus 2. So that x minus 2 needs parentheses. Then equals 2 times 6, which is 12. Okay, now because this 3 is being multiplied by the entire x minus 2, you need to distribute that in. So you get 3x minus 6 equals 12. Now it's just a two-step equation. 3x equals 18. Your final answer is that x equals 6. Okay, so it's just working backwards with slope where you know the slope and you're missing one of your x or your y values. This next example goes through the same process. Okay, I'm trying to find the value of x so that the line passes through the points x, 4 and 6, -1 with a slope of 5/6. So I know my slope already. I know my m is a 5/6. What I don't know is my x1 value. So my y2 minus y1 becomes -1 minus 4. So my y2 minus my y1 over my x2 minus my x1, which is what I don't know. So 6 minus x. Again, you have a proportion, so you're going to need to cross multiply. Okay? This 5 is being multiplied by the 6 and the negative x, so it becomes 30 minus 5x. You have to distribute that 5 to both pieces. Equals -30. Again, two-step equation, you should get an answer of x equals 12. Okay? So those are your slope problems where you're missing one of your point values. So you work backwards and cross multiply. Okay? Now we start into rate of change application problems. So it's word problems, but the word rate of change tells you how fast the output changes relative to the input. So remember, your output is your y values, how fast that's changing, how fast your y values are changing compared to your input, which is your x values. This is the same thing as slope. That's what your slope is finding. Change in your y values over your change in your x values. So the change in your output over the change in your input. Okay, so its rate of change is the same thing as slope. But they are word problems, so you're going to have to pull out the important information. All right, so let's jump to this example here with a table. So the table below shows the cost of using a computer at an internet cafe for a given amount of time. We want to find the rate of change in cost with respect to time. Okay, so, and we underline rate of change. When you're asked to find rate of change, you're finding the slope. So again, rate of change means the same thing as slope. And I'm finding it in cost with respect to time. So this cost has to be my y values. Okay, that's what I'm finding, my rate of change in cost. So that's my y value. With respect to time, so relative to the time, so that's your x value. Okay, you have to be very careful to make sure you know specifically which is your x and which is your y. Okay, you cannot interchange those. With most examples, you cannot interchange those. So in this case, your y has to be your cost, your x has to be your time. Typically with any of these problems, if you're dealing with time of any sort, so whether it's actual hours, if it's minutes, if it's months, if it's years, your time is always going to be your x values. So now we're finding our change in y over our change in x. Now we have two different ways of doing this. Okay? Change in y means if what's happening between your y values. So between 7 and 14, I'm adding 7. Between 14 and 21, I'm adding 7. So my change in y is a positive 7. My change in x is a positive 2 because between these two x values, I'm adding 2. Between these two x values, I'm adding 2. So my change in x is a positive 2. That's how much it's changing between each x value. So 7 over 2 is the same thing as 3.5. Now remember, you're doing your y values was your cost, okay, was your dollars per hour. So it's $3.50 per hour. Okay, it was dollars over hour, so dollars per hour. Now another way that you can solve this is just by your normal slope formula. Okay, choose 2 points from the table and calculate the slope like you have before. So you could pick any set of points. Now remember, your points are vertical here. This is your x values, these are your y values. So you have the point 2, 7, 4, 14, or 6, 21. You pick any two out of those. Okay, so we chose 2, 7, and 4, 14. Okay, those are my 2 points. You use your slope formula of y2 minus y1, so 14 minus 7, over your x2, which is 4, minus x1, which is a 2. You'll notice you will get to the same answer as long as you calculated it correctly. 7 over 2 is the same thing as 3.5 over 1. So I have $3.50 per 1 hour. Okay, because remember it was dollars over hours. So $3.50 per hour. All right, a few more examples. So the table below shows the total number of miles that a plane had traveled after a certain number of hours. Okay, so we're looking at the total number of miles that a plane went after a certain number of hours. Okay, so it has their hours listed here, their miles listed in this column. Okay, now remember that your time should always be your x value. So hours is your time, that should be your x. So in this case, miles has to be your y value. Now if I look at, I want to find the rate of change represented by the table. So I'm trying to find the slope here. Now again, you can do this 2 different ways. You can pick out 2 points and calculate the slope, or you can think about the change in y compared to the change in x. Okay, so either way, and I have the work for both. So change in y, if you look at it that way, between 700 and 1300, we're adding 600 miles. Between 1300 and 900, we're adding another 600. So you can see that the y values are changing by increasing by 600. Your x values are all increasing by 1. I go from 1 to 2, 2 to 3, 3 to 4. Okay, so my change in y is 600. My change in x is a 1. So 600 divided by 1 is 600. Okay, and again, it's miles per hour. So you have to have units with these word problems. You can also calculate it by picking any 2 points. So remember, these are your x values, these are your y values. Okay, so we used 1, 700, and 3, 1900. And then just calculate the slope like normal. You will still get to 600 miles per hour. Next example, the fuel tank for a power generator. It contained 13 gallons. So the generator ran continuously from 1 p.m. to 4 p.m., after which 7 gallons of fuel remained. What was the rate at which the amount of fuel decreased? Okay, so again, we're starting with 13 gallons of fuel for this generator. It ran continuously, so that means it never stopped. From 1 o'clock to 4 o'clock, it never stopped. Right? After which 7 gallons of fuel remained. So I started with 13. From 1 to 4 it ran, and now I'm down to 7 gallons. Right? We want to know what was the rate of change that it decreased. Okay? I know that I went from 13 to 7. I know that it decreased. But I want to know at what rate. So per hour, how much did it decrease? So I have 2 points. I have 1, 13, because at 1 o'clock, when I started, I had 13 gallons of fuel. So again, your time is your X value. So here is my 1, and I had 13 gallons, which is going to be my Y value. Then at 4 o'clock, my X value, I ended with 7 gallons. So my point is 4, 7. So you have to create 2 points from that information. Those won't be given to you. You have to create those. It's important to figure out first which one is going to be your X value and which one has to be your Y value. That will help you with setting up your points. Now you're just going to calculate the slope. You have 2 points, so 7 minus 13 over 4 minus 1. That gives you negative 6 over 3, so you want to reduce that to negative 2. Right? Now it's important that this should be a negative value. If you were decreasing in fuel, your rate of change should be negative because it was decreasing. So pay attention to that word. If you have decreased in your problem, but you get a positive for your answer, then that should be a big red flag that you made a mistake. It's losing 2 gallons per hour. Okay, because remember, your Y value was the number of gallons. Your X value was representing your number of hours. So I'm losing 2 gallons of fuel per hour. Right, 2 more examples. So Mrs. Green wants to make some toys for a store. She starts working at 8 a.m. and stops at 12 p.m. every single day. So the store needs 120 toys and requires Mrs. Green to make them in 3 days. What must her average rate of toys made per hour? Okay, so her average rate, it's asking you for slope there. So we know that she has 120 toys in 3 days. So I'm thinking about slope, but I only have 1 set of points here. Okay, so I need to reduce that to figure out, okay, if she's making 120 in 3 days, I need to reduce that to figure out how many is she making in 1 single day. So you divide it. 120 divided by 3 gives you 40 toys per 1 day. Okay. Now, we were told that she's working 4 hours a day. So from 8 a.m. to 12 p.m. is 4 hours. So if she's making 40 toys per day, but she's working 4 hours each day, now I need to figure out, I need to simplify it again. I need to take it down to hours. So 40 toys divided by 4 hours means that she's making 10 toys per hour. Okay, so this is slope, but in a different format. Okay, you're doing a 2-step problem where you have to figure out first how many toys is she making in a day, and then break that down even further into hours. Okay, in this last example, they give you an equation. Okay, y equals 17x plus 15, and they explain it to you. Okay, but we want to figure out what does the term 17x actually represent in the equation. So she gets paid a fixed hourly wage plus $15 a day for meal expenses. Okay, so that 17x is her fixed hourly wage. It's how much she earns per hour because it's 17x, so it's 17 times the number of hours that she works. Okay. The 15 then represents the amount that he or she gets each day for meals. So her employer pays her an extra $15 to buy food with for the day. Okay. So 17x is representing how much she's earning per hour, and then the 15 is representing her extra amount of money that is given to her to buy food. Now again, this was rate of change applications and finding slope, which was your missing values. Okay, this was concept number 2 for quarter 2.